Okay, double angle formulas, power reducing formulas, half angle formulas are the next topics that we're going to tackle here in this chapter. And this is where I left you on the last video. I said please go ahead and get those started in your notes for the next section. And this is what you should have come up with for each of these expressions. Sine of 2u is 2 sine u cosine u. Cosine of 2u, just straight out using the formulas, cosine squared u minus sine squared u. And with the tangent of 2u, you should have ended up with 2 times tangent u on top over 1 minus, there's a minus sign, tangent squared u on the bottom. These formulas are all in, they're in the right column of that formula sheet that I've both taken a picture of and that you have access to in your book. You do understand and recognize and realize if you're flipping back and forth right now that cosine of 2u has 2 other ways that it's written as well. And those ways come from the Pythagorean identities. I know that, and I'm going to write these in erase and then write and erase. I know I can write cosine squared of an angle as 1 minus sine squared of that angle. And so then if I combine like terms, I get 1 minus 2 sine squared u. Okay, that's equivalent to that blue underlined statement. Okay, or similarly, if I come over here, then I recognize that sine squared of an angle is 1 minus cosine squared of that angle. And because of that minus sign out in front of it, okay, the minus and negative becomes a positive. I can write that as 2 cosine squared u minus 1 if I'd rather. This is the only one where we have lots of choices, meaning 3. We have 3 different ways. If I see a cosine of 2u on my paper and I need to write it as in terms of angle u instead of 2u, I can write it all in terms of sines, I can write it only in terms of cosines, or I can write it using both, depending on what I need and what's most beneficial to me in that problem. So keep these handy. Actually, I will just do the dual page thing so we can see them there for a little bit. Okay. But if I have the most horrible mess in my notes, if I had a way to take a picture and show you, you would laugh at me. So in general, if I just start simple and say I have sine 2x. Okay. Also, it's very important, and I need to say it out loud, even though a lot of students don't always feel comfortable with this. But the sine of 2x is not the same thing as doubling whatever sine of x was. Okay. In fact, we have that relationship on the left. It's 2 times the sine of regular x times the cosine of regular x. If I have a 2u for my angle, then sine of 1u and cosine of 1u is what I have on the right, okay, with my coefficient 2 out in front of it. So if I want to write the sine of 6x, we need to understand, and if you need to write this step in here, please do that. Okay, 6x is double 3x. So I will have a 2 times sine 3x times cosine 3x. There's a 3 there. If I want to write sine 10x, I can write that as 2 times sine 5x times cosine 5x. Or if I open my mind a little bit, it's correct to do this, not something we need to do very often, but if I have just plain old regular sine x, I can think of x as being double half x. That says x over 2. By the way, it's kind of fuzzy. So I can say, well, that's 2 times sine of x over 2 times cosine x over 2. Okay, very similar very similar, I can put things back together. I want one page, so I'm not... Oh, that's still ginormous. Excuse me for a minute. I'd like that to be that big. Maybe I'll write it in... Maybe I'll do blue. We know that sine of 2u is 2 times sine u times cosine u. Sometimes when I'm given, maybe I have something like 8 sine x cosine x. Again, if you need to write this step in here, please go ahead and write it down. But I have 2 sine x cosine x times an extra 4. I can pull a 4 out of that 8 and have the 2 left over. The stuff in parentheses right here is equal to sine 2x. So these guys are x's. So I'm going to double the angle and take 2 times x when I come over here. Okay, 2 times sine x cosine x is sine of 2x. Maybe I have 2 times sine 4x times cosine 4x. Maybe I have negative 4 times sine 7x times cosine 7x. Maybe I have just plain old sine 3x cosine 3x. Go ahead and I'm gonna make it a little bit bigger. Sorry, OCD. Go ahead and take each of those expressions on the left, pause the video, and see if you can put them back together, and use a double angle formula correctly on that. Okay. On the next one, when we write it as a single term, if we have 2 sine u cosine u, here's my u, here's my u, I have to double u. I have to take it times 2. And so if we double 4x, we get 8x. So this would be sine 8x. On the next one, and again, if you need to write this middle step over here, please do that. Some of you will be able to see and absorb this step with your eyes, and that's okay. But I need 2 times sine something times cosine something, and it'll be sine of, again, double the angle. So if 7x is u, then I need to double the value of u, and 2 times 7x is 14x. The negative 2 out in front from the coefficient. Okay. On the third one, again, I have to be a little bit more creative. Some of you may have seen this, and some of you maybe not. But if I need to have a 2 with the sine x and the or sine 3x cosine x, I can do that. If I think about it being 1/2 out in front, that still says 1 sine 3x cosine 3x. And so again, u is equal to 3x. And if u is 3x, then u times 2 is 6x here, and my 1/2 out in front that I need to have. One more example from this video, and then we'll go into some more power reducing things is what we'll do next. We can solve, forgot I didn't make a new document here, we can solve equations now. Okay, and we've been practicing that off and on since section 2-3. And we know from before and in the past, if we were going to have something that was different, it was maybe a sine x and a cosine x, or a secant squared and a tangent of an angle there. But if I have sine 2x and a sine 1x in my problem, I can't combine them together in any way. And so if the angles are ever different, I need to at least be able to reduce it down to where the angles are the same across the board. Okay, there's very much not a way to turn sine 1x into a sine or cosine or something of 2x. But I know from the practice we've just done that we can take sine 2x and write it as 2 times sine x times cosine x. Now again, even though we have sines and cosines mixed together, I know that anytime I'm solving an equation, if I can factor it and use the zero factor property, that's going to be my most direct route to my path, my most direct path to my solutions. So here I notice that sine x is in common both times, in both terms. And then once I factor, I can set each factor equal to 0 and solve for x. First solve for sine or cosine x, and then go back and sign for x. So on the right here, cosine x would be 1/2. Since I wasn't told that I can be lazy and just give the 0 to 2 pi solutions in that interval, I have to give all of the solutions. And so I know that sine is 0 at 0 and pi. I know that the sine function is 2 pi periodic. So if I add multiples of 2 pi to those values, if you wanted to leave the top one is 2 in pi and the bottom one the way it was, I'm not going to argue with you too much. I'm not going to argue with you too much there. But do notice on the bottom, I can factor out the pi. And so on the left, that's going to give me all even multiples of pi. And on the right, that's going to give me all odd multiples of pi. So really the most concise way I can write this is say, I just need an integer times pi. 1, 2, 3, 4, 5 pi will all work because I have the evens from here. I have the odd ones from there. And so that is all integer multiples of pi. On the right side, I know the cosine of pi over 3 is equal to 1/2 in quadrant 1. I also know that quadrant 4 is the other place the cosine function is positive, and that's at 5 pi over 3. So then I'm going to add all of my multiples, all of my 2 pi multiples to those values, and here are the solutions from that factor. So lots and lots, infinite number of solutions from each factor, but those are all the solutions to the equation sine 2x minus sine x equals 0.